A very good afternoon, everyone. Today, I, Darshpreet Kaur, Vice President of Department of Computer Science, on behalf of Team Cybernauts, the Tech Society of Mata Sundari College for Women, would like to thank you all for engaging us for this insightful research talk on behavioral biometrics towards a securer, smarter, and healthier world. So before proceeding towards the session, I would mention some rules and regulations which you all must follow during the session. Very first rule is kindly don't switch on your mics and cameras or present your screen in between the session. Secondly, in case of any doubt, you can mention the same in the chat box. All your queries will be handled by the speaker. Thirdly, make sure you all fill the feedback form before leaving the meeting. The feedback form link will be circulated in the chat box towards the end of the session. Thank you. So, before commencing towards the session, I would like to extend my warm regards and sincere appreciation to Principal Ma'am, Professor Dr. Harpreet Kaur, Course Coordinator Dr. Kiranjeet Sethi, and Department Coordinator Dr. Nidhi, and all other faculty members for their constant guidance and support. I would also like to welcome all other participants who joined us today for this research talk. Now, I would like to invite Department Coordinator and Convener of the session, Dr. Nidhi, to introduce the guest of honor and resource person for today's research talk. Welcome, ma'am.
Thank you, Darshpreet. Now I take this opportunity to extend a warm welcome to all the participants and convey my heartfelt gratitude to our speaker, Dr. Rajesh Kumar, who is an incoming assistant professor, tenure track at Hofstra University, United States. He earned his PhD in computer science from Syracuse University, New York. He completed his master's in mathematics from Louisiana Tech University. He also has MCA and MTech both from Jawaharlal Nehru University, New Delhi. His research basically focusing on harnessing the power of ever-evolving smart devices, wearables, and machine intelligence. More specifically, if I need to mention, he basically applied machine learning techniques to solve problems related to security, privacy, healthcare, and social networks. He has published a total of 14 or more research articles, most of which have appeared in IEEE and ACM conferences and transactions, garnering him over 477 citations. That makes it 34 citations per article on an average. He was recently recognized as one of the best reviewers from IJCB, the top conference in the field of biometrics. He collaborated with researchers across the globe, including those in India, Italy, and United States. Before diving into full-time research and teaching, he served as an executive officer at Maharatna Company, Steel Authority of India Limited. Today, he is going to present a part of his research about an hour from now, and it would be greatly appreciated, as Darsh mentioned, to mute your mic and cameras and put your phone also on silent mode. And if you have any question or any query, you can write it down or jot it down in a chat box, which can be taken care by our team and the speaker. Now, without further ado, I would like Rajesh to take it away. Rajesh, over to you. Thank you.
Thank you so much. Thank you, Nidhi. Thank you, Darshpreet. First of all, thank you for the opportunity, and thank you, Principal Ma'am, for this opportunity to speak with the bright kids. And I always love actually teaching, talking, learning from young kids. So this is a great opportunity for me. I would appreciate if you can turn on your camera. Then please do it, because I don't want to be talking to the blank screen. So let's do that if you can. If you cannot, that's perfectly fine. So I'm going to present on behavioral biometrics, as it has been advertised, kind of. So toward a securer, smarter, and healthier world. And I think the introduction was probably good enough, and now giving me so much pressure because I have done so many things. So now this is a pressure on me that probably should be a good talk and probably not make you feel sleep. So a short bio, probably, which was not included in the intro deliberately. I'm born in Jaunpur, Uttar Pradesh, and I did my undergrad from a university in Bhopal, MCRP University, which is known for journalism. Then moved to New Delhi, JNU. There I did my NCA and then was enrolled to MTech and PhD program. But then I got a job at SAIL, so I left after doing MTech. And then 2 to 3 years later, I realized that that's not for me. So I came back to Louisiana Tech here on the left, you can see on the map. So at Louisiana Tech, only within 13, 14 months, I completed a degree in mathematics and then moved to Syracuse for PhD in computer science. So things work that way. So let's talk about the outline of presentation. I gave that short bio introduction so you could connect with me, that I'm from I'm one of you, right? So you could be able to connect and maybe able to ask questions and not shy from questions. And I would love to have questions. So the outline of presentation is going to look like this: background and motivation. So I'm going to give you a little bit background of my research area and then why this research is important. And then I will walk you through the research process that people generally follow in this field. And then we will talk about some results and then summarize the results, as well as followed by challenges and opportunities. And then we'll have question answer. As Dr. Nidhi said, that you can ask question in between, you can just put it in the chat. And if I see the chat, I'll be able to answer. If there are things that is bothering you, that I don't know authentication, what it is. So if you don't know authentication, if I have not explained it, you may not be able to understand the whole presentation. So it's better to ask in between, and I'm perfectly fine answering that. So let's go through background and motivation part. So this is the overview of overall what I'm going to talk about. A lot of things that we have adopted in our life in the last probably 10 years, like smartphone, smart ring, laptop, BCI headset. BCI means brain computer interface headset. So it's generally used for meditation nowadays. You can look for this particular device, but it captures your head movement because it has sensors, same sensors inside it, which you have in your smartwatch and smartphone. Similarly, tablet, it also has a lot of sensors. So what do they do? These devices produce a lot of data, and that data could be in the form of time series signals, timings, and coordinates, and so on. And if you analyze these data using machine learning techniques that we have very recently evolved so much, I mean, for the past 10 years, very recently means it has been there for maybe more than 50 years, but all of a sudden we started using all these techniques because we got more powerful computers to analyze the data. So after combining these two, what you could do is you can create a much more secure and smarter and healthier world. And let's talk about what is securer. What do I mean by securer, right? So you might have seen all these things in your life, real life, like surveillance at some particular high security environment, maybe making payment, or maybe entering to a highly secured building, airport, match on card, biometric ATM, smartphone access. So all of these are scenarios where people try to present themselves in terms of either their fingerprint or their face or their iris or their palm print. So all of these things get captured, and then all they do is they verify your identity, that whether you are the same person as you are claiming to be. And that's called authentication, and it's a two-class problem. And generally, so it's a two-class problem, means those classes are either genuine or imposter. So you could be either the same person or it could not be you. So there are two classes that we'll try to classify between. Just wanted to introduce that part. So authentication, so far we have been doing authentication using something that we can memorize, which is pattern and PIN and password. So one could argue that what is wrong with them. So let's say some of us get like 100 texts in a day, and every time you have to enter a 6-digit or 4-digit PIN, right? So it's bothering, right? It's better to just take the phone in your hand and automatically it opens for you because it just scans your face and all of you are able to see the text from your friend. So just to see hello or hi from your friend, you have to type. So there are several other disadvantages, but this is one of the inconvenience that we face, right? And pattern people can see from far away, and then they could probably remember what type of pattern that you have. In 2014, our own research lab demonstrated that, okay, let me Is it playing? Demonstrated that one can just record your video from like far away, maybe a couple of meters away, and then they can know that what pin you have, and that video will be recorded in such a way that nobody will suspect that this is happening. So let's watch this video for 1 to 2 minutes. I was sitting in the library, and that's what I did. My friend texted, and I just took my phone and then started typing my pin. And then the video was recorded at that time. What we are doing is we are tracking the movements of the hand and then movement of the phone. So we could compute the relative movement. And based on that relative movement and the knowledge that in Android, the keypad is basically fixed, which we'll see in a minute, in a few seconds actually. So wherever the key press was, my hand went down. So you could see that A, B, F, Z, those are key pressed locations. And based on these locations, you can actually infer what pin was typed, because the last key was always okay. So you can just backtrace it, right? So that was the research done in 2014. And based on that, it was actually later funded by Federal Bureau of Investigation, which is FBI. You might have heard of that organization, about that organization in movies mostly. In 2017, somebody applied the same idea to crack the pattern. Like they could record you from a place where you would not suspect them to, and then they will know your pattern. And similarly, passwords. So what do? We move towards face-based authentication, and we move toward fingerprint-based authentication, and then iris, and then DNA. DNA is not so popularly used, especially in our daily life, but they are used in forensic sciences. Generally, they find something and they try to match the DNA. So biometrics generally solves two problems. One is authentication, which I told you, that verify your identity, whether it's you or not you. And second is identification, where we have a large database. For example, you go to the airport and they have a database of everyone who has been issued a passport or a visa. So they will just search you in their database. And it is an N-class problem where they are comparing your credentials or your patterns or your whatever you have provided to them. They are comparing with everybody in the database. So it became like comparison with N things, N problem, right? So we will not be talking about identification. We will be only talking about authentication, which is a two-class problem. But the problem with this kind of fingerprint, face, and other iris, they are becoming popular via your Apple devices and also Samsung devices, or maybe Android devices, I should say, Android and iOS both. So what are problem with them? Somebody can forcefully take it, and you may not see it happening in the context of India or somewhere else, but you know, it could be a thing when a terrorist captures an army personnel, and then they would try to take the fingerprints so they can take all the information that our army personnel may have in their device, which is locked by their fingerprint and face, right? So you can be intoxicated, or while you're sleeping, your fingerprint can be taken, and then it will unlock your device, right? If somebody is nearby you, close to you, they can easily you know, break into your phone. Also, right after its launch of fingerprint ID in Apple, there is a club in Germany. It's called Chaos Computer Club. They generally do this. They generally test all the security systems which gets launched with public devices, especially when Apple launched a Touch ID on their iPhone for the first time. These guys actually broke into that easily, and just by making another fingerprint which the genuine person had left somewhere, right? So, and they made a statement, big statement, as we have said now and more than years, fingerprints should not be used to secure anything. You leave them everywhere, and it is too far easy to make a fake fingerprint out of that lifted print. Since then, fingerprint biometric has been studied for attacks a lot. And then, so my field is not fingerprint, and I will tell you why. But fingerprint is heavily used system nowadays, just primarily because it offers a lot of convenience. So you will see always that there is always a trade-off between convenience and the level of security that we will get, right? So the more convenient the security system is, the easier it could be to break that system. So similar to fingerprint. And then whichever provides us the best trade-off, that we start with that. So drawbacks of these systems, what we have discussed: PIN, password, pattern, fingerprint, face. And so drawbacks of this system is they offer only entry point verification. What do I mean by that is, so whenever you take your phone and then scan your fingerprint, it opens, right? After that, it doesn't track if you are using it or somebody else is using it, right? So what if there is a mechanism that your phone knows it's you, right? Automatically, by the way you hold it, by the way you type on it, by the way you swipe on it, by the way you walk with it. And so that is probably the next generation authentication, or maybe new systems that we might be using in future. And that's why a lot of research has to go in. For example, you could be wondering that this fingerprint, all of a sudden it got into phone, but before that maybe more than 10,000 papers were published on this same technology, right? So a lot of fundamental research goes into these things before they become product and they become useful for the public. They have to be verified from all possible ends, right? So first weakness, big weakness is once you log in, after that anybody can use the device and your device will not know whether it's you who is using the device or not, right? Second is intrusive and time consuming. Like I told you, that they require you to enter something. They require your attention, some sort of conscious and unconscious. You are giving fingerprint, that's your attention. It is taking your attention. Time consuming. Can be taken forcefully or while intoxicated. We have talked about. Unsuitable for constant or high security environments like military bases. I told susceptible to spoof-based circumvention. So someone can just take your fingerprint, probably recreate it, although they will have to do a lot of work. So what is next? My question was, what is next? Unfortunately, it seems like I cannot see the faces at the moment. So can you tell me what are the things that you can use to verify the identity of a person, probably continuously, as long as the person uses the device? You can put the answer in the chat if you have, so I will have some feedback. So what is next? I'll probably answer it myself for now. So let's think about this quote by Dale Carnegie, where he says that there are 4 ways and only 4 ways in which we have contact with this world. We are evaluated and classified by these 4 contacts. First, what we do. Second, how we look. Third, what we say. And fourth, how we say it. So based on this, you could say that, a person can be classified based on, their behavior, which is what we do, their physiological attributes, for example, fingerprint, face, and many other things that we just discussed, how we look, and what we say. So this is referring to basically voice and maybe writing, handwriting, and other things. You could say a lot of things without even speaking anything. And how we say it. How we say it is important, because even if I say something and you say the same thing, the way you say it would be different than mine. And this is what behavioral biometric study actually exploit. So even if you type the same password, you will not type like me, like the way I type it. And we'll take a look at that. So the answer to that question is behavioral biometric is the next thing that probably will add on to the previous authentication system, or will become a standalone mechanism to verify the identity of a person. So what is behavioral biometrics? It is important to learn that. So any behavioral pattern that meets the following criteria could be classified as a behavioral biometric, right? First is universality. So universality, these criteria are defined by one person, Anil Jain, who's from IT Kanpur, but he's a professor at Michigan State University. He is very well known in the field. He has more than 230,000 citations. I think I remember last time I saw. It keeps increasing every day. So he is like a godfather in biometrics. Very simple person. Anyway, universality means whatever the pattern that you are considering, everybody should have it, right? So whoever are the people of interest, they should have it. For example, you are considering walking patterns, right? There are people who may not be able to walk like properly, right? So unfortunately, but and then you're looking at swiping patterns. So there are people who may not be able to swipe, who may be able to just speak and give commands to the phone, right? So we cannot, assume that everybody has it, unless, for research studies, we generally do that. But in general, that we should not exclude those people. First thing, that anything that you're considering for as a behavioral pattern, everybody in the population should have it. Second thing is collectability. So one should be able to collect that data, collect that pattern. Why fingerprint was not so popular 30 years ago and it is popular today? Anybody has any thoughts about it? Although the studies on fingerprint were conducted a long ago, and there were a lot of papers published. So one of the reasons was that we were not able to collect fingerprint as efficiently as we are able to do now, because fingerprint sensor is available now in a smartphone, which was not the case a long ago, right? We used to have a box and we used to go for Aadhaar ID and we used to have like all the scans. So nobody will kind of carry that fingerprint box everywhere or buy an external hardware. So generally, whenever these consumer devices start having these luxuries of collecting patterns of people, then we can start assuming that, okay, now nobody has to buy an extra hardware, and let's try to do it, study on the phone and so on. So collectability is an important factor, criteria that pattern has to meet. Uniqueness. So basically, what do the uniqueness mean is that particular pattern should be distinct among the users. For example, the way you walk and the way I walk is different, should be different if walking pattern has to be considered as a behavioral biometrics. Fourth is permanence, means that pattern should not change so quickly. For example, you're walking in a way today, and then tomorrow you are walking differently, and maybe day after tomorrow your walking pattern changes so drastically that it doesn't match with the pattern that you produced 2 days before. So one could argue that, okay, how do you measure that? Maybe you can collect data at many different days, and then you can do that. So fourth is user acceptability. This is an important criteria that, whatever pattern that you're considering, users should be able to, users should be willing to give that pattern to you. For example, a lot of people may not like to give their fingerprint. A lot of people may not like to show their face to the phone, like every time it captures your picture. Although they say that it will be stored, it will not be stored. Maybe it will just use for matching purposes. It will not be transmitted anywhere. But even then, we are kind of sort of shy from giving fingerprint when we are in different situations. So you cannot consider anything to be a behavioral biometric unless it is acceptable to the users. Circumvention, this is an important part, that nobody should be able to mimic the same behavior. Like if I'm able to walk like you, then that means that pattern should not be considered as a behavioral biometric. The next is performance. So whatever pattern you are capturing, it should be easy to process that pattern and produce the result in terms of whether it is coming from genuine person or imposter, right? So the fourth is integration. So whatever technology you develop, it should be integrable in whatever the devices we currently have, right? So these are some important criteria that biometrics should meet, a pattern should meet to become a behavioral biometric. And all these criteria equally apply to physiological biometrics, which is fingerprint, face, and iris, and other things there. So let's talk about some examples. So 2013, a study actually showed that the touch pattern on your phone, the way you swipe, the way you zoom, pinch, scroll, or whatever you do, can be considered as a behavioral biometrics, right? And that study was conducted on, I guess, 50 people, and then they showed that it attains a good accuracy in terms of uniqueness. So this is just an example. Second is your keystroke, right? You type on your laptop, you type on your smartphone, and then you can see that. Okay, I'm trying to write something, but it's not happening, which is fine. So you can see on the right side, these are the buttons, key buttons on the keyboard. When you press them, all these timings gets recorded, and just those timings will form a signature for you. Let's say if I'm writing Mata Sundari College for women, So this phrase, if I'm writing, I will have different press time and different release time for those keys that has to be pressed to type that, right? So, and then if you have to type it, you will type it differently, and those timings will actually differ so much that it can be considered as signature of yours and signature of mine. And this study has been there for like 20 years and generally known as keystroke dynamics. But it was not done on smartphone, right? It was done on mostly on a laptop or general keyboard, desktop keyboard. Similarly, walking pattern, which can be captured in so many ways that you can think of. So first, you have a phone in your pocket. Phone can collect your walking pattern because phone has sensors, and those sensors, the most popular sensors that have been used to collect your walking patterns are accelerometer and gyroscope. Accelerometer generally just captures the acceleration or the movement, the acceleration in the movement. Gyroscope captures the rotation when you move, right? And these two sensors, there are 12 of them or maybe more. These are called inertial motion sensors, and then you can access their readings by using Android API, and that's how you can develop an Android application to access these readings easily. The same sensors are available, not all of them in smartwatch. So you can basically collect someone's walking pattern from their smartwatch, right? And this is how the data looks like. It looks like time series, and you could see how regular pattern one has when they walk, right? And then also it shows that how different users have different walking patterns, just looking at the data. We have not even dived into the features. We have not dived into the powerful machine learning algorithms that we have nowadays, right? Okay, this is a movie, I think 2014 movie, but I'm going to play it and so let you.
Through the central computer terminal located there. To reach the terminal, you'll need to pass the main gate.
Excuse me, sir. Voice is not audible of the video.
Sorry.
It is very low. Voice of the video is very low.
Dash, it is audible at my side. I guess.
So I think
check your.
It is audible. Just the voice is low, ma'am. Just the voice.
Yes, ma'am. The voice is low. It is audible, but it is very low.
Okay, Rajesh, can you please?
I increase the voice. I don't know how much, but this is the full that I can do. So maybe you increase the sound.
To reach the terminal, you'll need to pass the main gate. Access the elevator with fingerprint recognition. And open 3 separate combination locks.
Well, that's easy. We just impersonate the agent who stole the ledger in the first place, and I get to wear a mask.
Unfortunately, even if you could make it through every other security measure, you won't beat the last one. That's because it's protected by gait analysis, the step beyond facial recognition. These cameras actually know how the agent walks, how he talks, how he moves, right down to his facial tics.
So what you're saying is no mask can beat it. We're busted before we even get into the vault, and I wind up in a Moroccan jail playing mummies and daddies with Omar the Strangler. Okay, I don't get to wear a mask.
And there's no other way into the computer lab.
No other way in.
So you just saw that, and then you realize that Gait is one of the most powerful technology to secure a very highly secure environment, right? But there is a way to breach it, and which is to replace the template, which is what they do in the movie.
All security data is stored offline in the liquid-cooled array. Here, inside the torus.
Liquid-cooled? You mean that thing is underwater?
Yes.
Yes.
Okay. So to get the ledger, one of us needs to enter the torus and change its security profile so that the other one can access the computer without being caught. That's the only way.
That's the only way. And before you ask, the system is designed to shut down automatically if any metal enters the intake.
No oxygen tanks.
All right, well, how long will it take to free swim from the intake to the service hatch?
2 minutes, with the current at full power.
What, then you just have to hold your breath for 2 minutes?
What about installing the security profile?
Well, that's going to be like a minute tops.
So I have to hold my breath for 3 minutes.
You can do that.
The more you exert yourself, the faster you consume oxygen.
Don't worry about him, all right? All he has to do is install the fake profile before I get to the gait analysis. You said it yourself, it's the only way. That doesn't sound impossible.
Okay, so now you saw that there was a security profile of a person who was allowed to go in, and then these people are trying to put a security profile for this guy who is going to go through that gate, gate-based security mechanism, right? So you could see that, what does biometric system do? That they collect your patterns first, and they create a template for you. They create a security profile for you, right? And then next time you're giving the same pattern, they try to match with whatever has been stored already. The good thing about such a biometric is it doesn't have to match 100%. Even if it matches like 90%, 95%, it allows you. It's not like password and PIN that it has to match every character and 100%, right? That's the advantage. But these profiles will be stored in a very high security environment. Unless you're a team of Tom Cruise, you would not be able to replace that, right? This movie clip has two connections. Of course, one is with biometric, another with Tom Cruise. And Tom Cruise was actually born in Syracuse, the university that I went to for my PhD, in case. Anyway, so let's move forward. You saw that behavioral biometrics are difficult to breach. And you also saw that gait can be captured by video. Here we will be talking about mostly about gait captured by sensors that are built into your phone or your smartwatch, right? So I think in 2015, Tim Cook, who is the CEO of the Apple, said in a conference that your key fob that you use to unlock your car will be replaced by your smartwatch, because your car will know it's you if you will walk towards it by wearing a smartwatch, and your smartwatch and your car, should say smart car, will be connected. Both will be connected. And if somebody else walks towards your car using the same watch, wearing the same watch, the car will not unlock, right? So this kind of security mechanism in future could be. And the same thing can be applied to the payments. So in future, you just have to have a smartwatch and go and make payments. You don't have to carry like 10 different cards, Visa, MasterCard, and blah, 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 right? So those will be most likely replaced. It's already replaced in a couple of places in the US. Another couple of scenarios where you can, use gait biometric is especially sensor-based airport security check, unlock smart cars, smart homes, smart offices, entry to secure premises like military bases. So here it is important to mention that most of our army personnel, it is difficult for them to use physical biometrics, for example, fingerprints, because they wear gloves, they wear goggles, but they walk in a very regular manner. So their walking pattern can be collected by a device or maybe a sensor in their shoe or somehow, and they can be authenticated automatically by those. They don't have to produce something to be authenticated. And also it applies to, planes, what do you call that? Cockpit in the plane. If you're a person who is flying the plane for you is a terrorist, then it's going to be a nightmare. And nobody wants that to happen. And so on. So you can see that there are so many scenarios where gait applies and so on. So voice pattern is another thing, another behavior, the way you talk. And one of the application scenarios I can tell you, when you call your customer care to change your PIN or password or maybe make a payment somewhere, they will verify you based on your voice patterns automatically. They will ask you whether they can do it, because nowadays there are a lot of scams that are going on, and people can have your information easily stolen, and then they will make a call on your behalf, and they will have the banks pay for something and so on. So they will steal your money just by impersonating you on the phone. But that cannot happen if they cannot speak like you. I mean, they'll have to forge your voice, but at least that will be very difficult to do. So you could see that all these systems, there is a level of difficulty to breach them. So all we try to do is we just try to make them more difficult to breach. That's it. Nobody can say that this is the most powerful system and it cannot be breached ever. So that cannot be said. got more examples of behavioral biometrics? Can you think of a behavior that qualifies all those criteria and that could serve as a behavioral biometrics? Anyone in the chat?
I have one different question. That when you were telling us about the factor where the computer can judge how we walk. So what if we just like get injured and for a few days we cannot walk how we usually do? So does that mean that we cannot just like where we won't be able to access our devices for a couple of days?
Right. So that's a very good question, and it has been asked before as well. Primarily because we know that that kind of scenario may occur to us. So what can happen is it depends on what type of injury we have. If we are not able to walk at all, then we'll have to fall back on many other biometrics that are there, like swiping, typing, and so on. You see what I'm saying? So maybe fingerprint. So that's why we study different type of biometrics, because they apply to different scenarios. And in some scenarios, you may not be able to produce that pattern, so you will be able to produce something else. You see, so yeah, so we'll have fallback mechanism. These systems cannot be standalone. Yeah.
Other day, I was watching a movie where the person has a visit to the dentist and his teeth are removed, quite a few of them. So naturally, the voice recognition that the door used to have, it did not have. So how do we, in such a scenario, how do we go about it?
Yeah, that's a very good scenario, and it had never come before, so it's new, but it's a good point. That's why these are fundamental research that we start with, and at some point in time, we will be able to do something that will cover that scenario. What I'm trying to tell you that sometimes even this study has gone not too far, but people have studied different shoe. What happens if I wear different shoe? Do I walk the same? What happens if I have backpack? Do I walk the same? So there are some characteristics that never change, even if you have different shoe or different bags and so on. But if you get injured, then that situation is not known to the machine. And that's why still these machine learning based models, they are not ready to be deployed. And that's why we need to study them as much as possible for all possible scenarios. And Radhika has asked question, would voice mimicking change of language used impact voice securing? Voice mimicking would, but you would not believe that how powerful these machine learning algorithms are, that even if somebody is trying to mimic and there is slight difference between the genuine person and someone who is trying to mimic, if there is a slight difference, that machine learning algorithms might be able to pick that difference. Although as a human being, we may not be able to see that difference, but machine is doing it. So machine will be able to pick that difference. And that's where we have to get actually. In fact, you would see that, this voice-based translation to text and many other things, machine has surpasses human, like human intelligence. It means if humans will do the same thing, they will be less accurate compared to if the computer will do it. And that's where probably we'll have to reach so we can trust machines more. All these are great questions, and thank you for asking them. Anyone has already thought of biometric, that behavioral biometric? So yes, so somebody has said that fingerprint also fades sometimes. So let's say in your childhood, your fingerprint may not be the same as you are now, and it may not be the same 10 years later. So all you do is, there are studies, maybe thousands of them already, to how to update the template, right? How to update the template. So every time you give your fingerprint and it's a success, automatically it might be saving at random time, and it will probably update its own model or update the security profile that you just saw for Gait. So those studies have been done, and then it has been demonstrated that they work. Any other question at this point before we move forward?
I have one question.
Sure.
This is like whatever we are talking about right now, the different kind of ways a system can like judge you, and they can like see how you walk, how you type, and everything. Isn't this like gets like a little scary of like how much information a computer have about us, and like can a computer knows everything about me, like how I walk and everything? So isn't that like a little scary? Like you yourself said that machines can surplus things that how whatever humans can do.
Yeah,
so that
it
I
is
feel
scary.
will
It is scary, and then a lot of conversation is happening among the researchers on this topic, that whether we are allowed to collect all these data, and then And you will also see that how scary it can become. If somebody gets access to all those data, they will be able to know what is your age, what is your gender, what is your weight, and whether you may have any disease. All these data, if they get leaked to somebody, third party, then they can be really scary. You're right, and that's a very good point, right?
Even leaked, but at the same time, if you're talking about artificial intelligence as well, so like if artificial intelligence somehow got like out of control from us, this is like a very hypothetical situation, I know.
It's not hypothetical.
But
it would be real in a couple of years from now, I guess. So
exactly. So why are we just like?
But I think humans are not
encouraging
going to give complete control to artificial intelligence. The AI is going to be a surplus thing. Like they will complement human. They will not probably operate away from human. That's what I would say. So don't get scared right now. I think politicians and all these people will make regulations. For example, we made regulation for nuclear weapons, right? That nobody will produce them further because they will destroy the world. Similarly, regulations will come for AI. So I think there are so many other ways that we can counter this problem which you're talking about. There might be way to countering these problems using a technology, but there might be way to counter them using regulations and law and all those things.
Thank you so much.
Okay, welcome. Somebody has asked which biometric technology by far is the best in terms of safety. I'm not sure what do you mean by safety. Security for sure. So I think fingerprint is the most accurate. Probably iris has surpassed, but again, you cannot compare them just based on their accuracy level, right? It depends on what scenario are you using them, and then how they are performing and how much. So you can compare them based on their accuracy, based on the amount of computations that they take, and so on. So many ways you can compare them. I have had a comparison table. I will probably be able to show it to you that which biometric technology is better in what aspect, right? Yeah, iris is much safer, but no, you'll have to pop your eyes to give that. So also cost. Somebody had mentioned cost as well. So all are these biometric, not very costly. It depends on if iris comes, iris scanner just comes. If they can just take a picture of your iris and then authenticate you, it's not costly. All they do is it has to get processed on your phone, and phone has pretty good computational power nowadays, right? So yes, I hope I answered those questions in the chat, and we can move forward and have more questions later on, you guys. So I'm so happy that I'm getting so many questions. So that's good. It's good. So most of them you can think of have probably been proposed or studied by many researchers. If you still think that you got one that has not been studied, send me an email. We'll publish together. So let's talk about as a student, how can you start a research in this area, and what is the process? What are the steps that do we follow, right? First thing is we try to think of a pattern that we think that could be a biometric. We start finding people to participate in our study. And we'll have all types of people, genuine, imposter, and imitator. You see on the left, genuine. And then you ask them to participate in the study in the sense that you may give a phone to them and then say, hey, I want your walking pattern for 3-4 minutes. Can you please just put this phone in your pocket and walk naturally? And you'll collect that data, right? So similarly, you can have 100 people, 50 people, 30 people. Many studies have been published on those many users and so on, right? So once you collect the data, you have to know how you pre-process the data and how you clean the data. So generally in Gait, I'm taking an example of Gait and swiping, also typing. So just think it from a perspective of a case study. But this whole thing applies to majority of the biometric systems, right? Whatever I'm going to tell you, research process. And then you divide the whole data into frames, because these time series are continuous data and you have to divide into frames, maybe 10 seconds, 5 seconds, based on whatever works for that particular biometric. So maybe 10 steps of walking steps of yours would be different than 10 walking steps of mine at a statistical level. Maybe your one step may not be as different as mine, but if you walk a couple of steps and I'm comparing those many steps, then your walking pattern would differ than mine. So you could see that what is the advantage of creating frames here and of 10 seconds, 5 seconds. So your 10 seconds of walking data would be different from anybody else, right? And then we extract features, and then we select features. And I will talk about why do we need to extract features, but I'm just going to give you an overview of the pipeline that we follow generally. And we store the selected features, and then we train a classifier. And once the classifier is trained and validated, we store the model, and then the testing part comes, right? So it's like you give 10 fingerprints of yours whenever you buy a new iPhone or maybe new device. It asks for 10 fingerprint that register yourself. It is called enrollment. So you enroll yourself in the system. So all those 10 fingerprints, there is a machine learning model behind the scene that is getting trained, and that model will get stored. Next time you give your fingerprint, it will automatically match with whatever the model is. It will supply your new fingerprint to the model, and model will tell whether this fingerprint is of the genuine user or not. So genuine and imposter, these are the two output that we get, right? So this is basically a very simple machine learning pipeline. You can say that, okay, this is a machine learning pipeline, but that's what we use in a typical biometric system. Excuse me. It's morning. I'm not used to waking up this early, so drink a lot of water probably to keep you awake. I'm awake. So there are 5 steps that we generally follow. I told you: data collection and pre-processing. And a lot of people have collected this data in a lab setting. So the challenges remain that what would happen if you collect this data in a not lab, means in more realistic setup. So those red part is actually, those are the challenges. And what would happen if, for example, you get injured? That is activity context, ma'am, someone had told, right? So all those contexts need to be studied, and the data in all those contexts needs to be collected and then verified that whether your idea works or not. Next is feature engineering. So you cannot just match the raw data. For example, if I try to match 2 faces, they may not be as distinct when you try to match the eyes, when you try to match the nose and your lips, another part of the face. You try to match them and you'll get more distinction. And we will talk about like what is the intuition behind it. Training the model, training the classification model and testing that model, and also evaluating the performance of the model, right? These are the 5 steps that we generally follow. Here is some example of data collection where I'm collecting data, swiping data, and then movement that gets generated when a person is trying to work on the phone, check the Gmail account, Facebook account, Chase is a bank, JP Morgan Chase, or maybe check the Twitter. All of these activities inherently produce these patterns. So you, on the left, you do all those things. On the right, this is what I see happening, right? Okay. I'll answer that question, Twinkle, later, the cloud stories. Let's complete that one. So thanks for the question. So here we are collecting your walking pattern, and this is how there are a lot of sensors on your device, and you collect your walking pattern using 2 sensors, 4 sensors, whatever. I had used 4 sensors, right? And so why do we need to do feature engineering? This is a kind of analogy that I thought that would help you understand. Let's say you go to a shop, and then that shop is giving you 3 types of juice, or they call it a smoothie in the US. So they sell you 3 types of juice, and then you took all those 3 and then try to drink and see what is the difference between them. So how would you describe, after testing it, you think that, okay, they are different, but how would you describe the difference? Like one is sweeter, another is less sweeter, and so on, right? Maybe you can do so, but how can you do so quantitatively, right? So that's the question. Maybe because they contain the same vegetables, so they are different vegetables, that's why they taste different, right? What if the label says that they contain the same vegetables? So all these 3 juices have the same vegetables, and those vegetables are named here: tomato, carrot, and celery, and cabbage, right? So if the label says that the first one, which is Del Monte, also has tomato, carrot, celery, cabbage. The second one, veggie, it also has the same vegetables: tomato, carrot, celery, cabbage. B4, it also has the same vegetables. So how do you distinguish them? So what you have to do is you have to see how much of a content of each of those vegetables are there in these smoothies, right? And it's called featureization. So and generally you can see that a tomato, there is more tomato in V4 than Del Monte, right? You can compare them based on the amount of those vegetables in those smoothies, right? So Next is feature engineering. Yeah, somebody said texture and flavor. Yeah, you can tell them, but here I'm talking about quantitative difference, which computer can read automatically. As a human, we are very good at identifying patterns. Like even if we have seen, faces, it would automatically say, no, this is not the same person. I think even after I'm looking at him, like after 5 years, it's not the same. So you are very good at identifying, but how would the machine would become as efficient as humans to identify those patterns? Machines have to be supplied these quantitative details that they can learn from, right? They are not, superficial powers that it could automatically happen. So here from swiping, we see the distance, point-wise distance, the angle, the arc, the speed, the pressure that you apply. All of these are featureization, and we compare them at feature level instead of comparing them at the raw level, right? Here typing, I told you already, those key press events produce key hold time and key interval time. So how much time you hold a particular key, and how much what is the interval that you take between pressing two keys, right? You could see there are a lot of key pairs here. I have on the left table, on the table below left. CE was one of the most frequent pairs that came. HA was another most frequent pairs. So similarly, I had 40 most frequent pairs, and then I selected only 30 of them just to make our system much more lighter, because it has to run on the phone itself, right? So here are how could you featureize the walking pattern. I'm not going too much into math because we don't have a lot of time, but here you can divide a signal into many other signals. One of the biggest inventions of 20th century is called Fourier transform, and all that basically means that any signal is made of, it is sum of many different signals. So if you can break those signals, like if I can break your walking pattern and in 5 different signals, and then my walking pattern in 5 different signals, and we compare the amplitude and frequency of those 5 different signals, then automatically your walking pattern would differ from mine, right? So we are looking at very micro level, right, details. So, and these are the methods that we use for feature selection. Not all the features. For example, if there was tomato, it had the same content in all of those smoothies, then tomato would not be a good feature to distinguish between those smoothies, right? So maybe the feature that had different content in all 3 of those smoothies will be a good feature, and you want to select those good features that distinguishes between those smoothies, right? And this is actually what we do in feature selection. A lot of features, and then this is how we plot and then see that how those features differ from each other when we plot 2 users data. This is KD plot, similar to histogram. You might have heard of it. And these are the most frequent pairs that I talked about. So classification models, it's machine learning. I'm not going into much detail. There are maybe hundreds of them already available for you to train and test. And I used some criteria to choose, and then I used 5 of them in my study. You can see KNN, logistic regression support vector machines. These are very well-known classifiers and very well-known names. They have been also applied in the past for different types of study, similar study. So we just use those classifiers because we cannot just run hundreds of them. So we have to make a choice, and we chose that based on these 3 criteria. Okay, so how do you test the performance of these systems when you are developing these systems? We test the performance of this system using 2 types of error rates. First is if you are being rejected by your own phone, that's called genuine rejection. If somebody else is trying to get into your phone and they are successful in doing so, that's called false acceptance. I think it's the second one should be false accept rate. I have probably copied and pasted, and that's also FAR is false accept rate, imposter acceptance. So these are the 2 error rates, but it's very difficult to compare 2 systems when you have 2 metric. So it's better that we create single metric so you can compare different classifiers, and that's why we have STER, which is average of those 2, half total error rate. And you can see all of these sensors and all possible combinations. These are the results that I have to show you, and these are on the left side. You can see these classifiers, how is their performance. I want you to look at the right bottom corner where 6% is half total error rate, means 94% of the time KNN based system gets it right. 9% of the time SVM based system gets it right. So this is the result in nutshell, right? So we are at around 94% accurate in identifying a person based on their walking pattern. Similarly, let's look at swiping and movements. 93.33% accuracy we achieved for swiping, and similarly for typing, 89% accuracy. And one could say that these accuracies are not close to what we achieve in fingerprint, which is 99.999% at some point and on some data sets. So these systems are not as accurate as fingerprint. So someone would ask, why do we use them? But the problem is these systems offer you continuous verification. They are not like just one point. So what would you like to have? What would you prefer? What system would you prefer? If some system is offering you only 1 point security with 99.9% accuracy, and another system is offering you 90% accuracy throughout the activity, which one would you prefer? Some of you might be intelligent. Why can't we use both of them? Yes. So that is how many researchers have proposed that you can actually have best of both worlds, means best of both of these technologies, behavioral and physical. How am I doing on time? May I ask? Do I have time to keep going, or we can just summarize? And okay. Okay, thanks. So to summarize so far, I hope you have enjoyed. So for Gait, phone movement patterns while swiping, typing are weaker biometric, means they have weaker accuracy, but compared to physiological, but they offer continuous verification, right? Fusion of multiple biometrics. So hand movement and swiping, if you fuse both of them, it improves the performance of the system by like a couple of percent to 1 to 3%. The idea needs to be tested on a bigger data set. I've used 50 users, 52 users. Some people have used 100 users later on. But it should be tested on maybe 1,000 users, maybe 10,000. It's very difficult to collect data, find those many people. And there are not those many people in the US. So maybe this kind of study can easily be conducted in India. So where we have a lot of people who we can invite and they can participate and give the data. So swiping and typing, you can see that, these biometrics can be used for online course or online exams. For example, if you want to give an international exam like TOEFL, test of English as a foreign language, or many other GRE or any other exam that you want to give. So how can they verify that it is you who is taking the exam? And I can tell you, you can type the answer and they can know it is you who has typed the answer, not anybody else, based on your typing pattern, right? So there are so many civilian applications that you can think of this technology, right? And you can take online course. So in US, they have defensive driving course. If you take that course, they reduce the premium on your insurance. So you have to pay for your car, right? And after taking that 4 hours of course, I can tell you that you will probably not overspeed ever in your life, because they tell you a lot of statistics and they make you go through a lot of exercises and so on. But they want to make sure that it is you who is taking that test, even from sitting in your apartment, that it is you who is taking that test, not anybody else on your behalf. You cannot just employ people, hey, take this 4 hours of test and it will reduce my premium by 10 to 20% insurance premium. Gait is suitable for very high security environments. We saw that, right? So to keep going, I'm just want to tell that what are the ongoing research and what are the challenges. One of the things that we want to test that what if somebody would deliberately try to do something to breach into the system? Can they do it? So in 2015 and 16, we realized that, okay, what if someone can design a robot to actually swipe like human? And we succeeded in that to a good extent. So there are people who are now working on, improving the swiping based mechanisms so robot cannot, succeed in doing so, in copying humans. So this was just ongoing research. And then what if somebody can walk like you? It has been 10 to 15 years. Maybe more than 10 papers in top transactions have been published, and they have said that it is not feasible, or it is very difficult that someone can copy your pattern, right? Challenges remain, like I said, beyond lab setup and feature engineering, and now we should move into deep learning and context identification. What if you're typing while you're standing? What you're typing when you're in metro? What you're typing when you're sitting in a garden? So how do those contexts differ? Because all of these studies have been conducted in a very constant environment, lab setup and so on. And how do you test? So to test a model, you employ some attackers and then say, hey, you try to breach this system. It's like software testing. You have a testing team all together to test the software that you have developed. Similarly, you have to have people who will test these kind of biometrics, whether if they are willing to, they will be able to breach the system or not, right? Yes, ma'am, there are a lot of data sets available for behavioral biometrics. I think, yeah, there are tons of them. Even I have shared some of mine. So yeah, there are. What other problems can you solve using behavioral biometrics? This is a problem that you can solve. If you have younger brother, he might have a lot of apps on his phone or her phone, or a younger sister, but maybe your grandparents have this type of screen. So you can customize user interfaces based on the information that you can infer from these data that your phone is generating. So for example, soft biometrics, I have that term keyword there. Soft biometric basically means that what is age, what is gender, what is your height and weight, all of these things are considered soft biometrics, based on which you can actually point to someone that he is very tall, or maybe she is she's very fair skin and so on. All those things you could say to identify a person. And some of those information can be actually inferred from the data that you are generating easily. And that data can be used to create smarter interfaces, smarter ad. For example, this woman was pregnant in 2016 and they were showing her the same ad, maternity pants. And then after in October, they were still showing the same maternity pants to her, which is pretty annoying. If they had this information automatically, that that woman is no more pregnant, so she would not be shown the same ad. So there'll be a smarter ad, which a lot of marketing companies might be interested in. Smarter social networks. This is very, very important slide, and I wanted to communicate it properly. There was a white male professor at University of New Hampshire who had 2 Twitter accounts, and he was portraying himself as on one account, he was portraying himself as a woman in STEM program. Means if you're a woman and if you're in science, technology, engineering, and management program, you get a lot of privileges. It's like a reservation in India. Here they have affirmative action, so they kind of give you so for example, in computer science department, if there are only 10 professors and 8 of them are male, so they are trying to bring in more women. So women will be given more preference over men. So what will happen is, such kind of things this professor did not like. So he tried to create an account and protest against and post a lot of nasty things. So he thought that as a white professor, if he will do that, then it will create a lot of problems for him. So he thought that why don't I become a female, and then why don't I become a female person in STEM program, and then I post a lot of things that I don't need such an affirmative action. I'm capable. All the women who are doing STEM are capable, and so on. So this is the context that I'm telling you, that he did a lot of damage to those women who may need those kind of preferences to come into mainstream. And so he was actually finally found. It was found out, and he was fired from the university. All I'm trying to say that just keystroke pattern analysis, when he was posting on one account and he was also posting on the other account, even though he was posting different contents, if Twitter was able to analyze the way he typed to women, would be the same way he would type on both accounts, right? So it would be easily, they would be easily find out that these 2 accounts are managed by the same person, right? And one person is portraying as a male, another as a female. So you can actually detect fake profiles online just based on the way they type. So I'm sure that India is suffering a lot from fake news and so on. A lot of parody accounts. A lot of people are trying to push through a lot of things through our throat. So, and he had 13,000 followers, and he was posting these kind of things. Any male who has ever thought about a woman in a remotely sexual way is rapist, and all of these things are being posted, right? So and then so posts were different types, right? But it did a lot of damage to the society, right? Also, this is from IIT Bombay, so you might relate that how even undergraduate researcher could do a lot of miraculous thing. I think this thing was done by undergraduate researcher at IIT Bombay. where they developed a smarter, I think, what do we call that? I forgot the name of the device. It's weird. So they can convert your sound, because chest sound is captured by this device. I know the Hindi stethoscope voice, it's right there, stethoscope. So it captures the sound, and then based on that sound, your doctor decides whether what you need. Are you doing well, or you're not doing well, and so on. So they converted that sound into digital format, which can be stored and then probably transmitted to your doctor. And during pandemic, your doctor can give you advice based on those digital transformed signals, right? So these are some things that you can do. Also, you can detect seizure attacks. Like, I know at least 5 people, and 3 of them have passed away because of the seizure attacks they got, and there was nobody to attend them. One of my friends in the US who was working, actually was worked with me for 6 months, and he was in his apartment alone, and he fell down in his bed, and he was never able to get up, and then he ran out of oxygen, so he passed away. So those kind of things can be avoided, because seizure attacks actually produce certain type of vibrations that could actually inform right away to someone nearby, or maybe trigger an alarm that somebody will go and attend them, and we will save lives. These are very important, and you could see that MIT is already working on this technology, but we need to experiment with these kind of ideas on actual smart watches that we have. Parkinson disease, a lot of our elderly actually suffer from slowness of movement, speed changes. Whenever they hold the phone, the tremor happens. So there is a disease that it's called neurodegenerative disease, and a lot of our old elderly people suffer from these. So this disease does not have any cure, but they can be detected and responded early on, and maybe our elderlies will not have to suffer. And you see, vibrations can be captured by accelerometer gyroscope, and they give you very clear-cut kind of data to specify that, okay, this person is probably going to have Parkinson in the future. So respond early. These are our sponsors. These are my students who have worked with me as undergraduate thesis students. So they have undergraduate thesis here, like they work on like 6 months on their thesis. They present it like PhD thesis, which is, it's a little bit lighter, much lighter than PhD thesis, but still they get exposed to some research. These are my advisors, mentors, and collaborators from different places, different universities. And my special thanks to organizers, including Dr. Nidhi, Dr. Pranjit Sethi, Professor Harpreet Kaur, for the opportunity to present my research. And much more special thanks to volunteer for making this talk happen. I'm happy to take questions. I think there is one question already, or 2 maybe, so I'll probably answer them first. Should I? So what is the role of RFID bands in biometrics, and what technology it is using to track? I have not worked with RFID, so I have not much idea about it. And very frankly, it is used a lot, especially here in, maybe capturing the speed and so on. But I don't have much idea about that. So maybe I need to read more, or maybe you need to read more to know. Are there standard data sets? Yes, there are standard. No. So, okay, I think I missed the question. Standard data sets. Unfortunately, these biometrics studies are relatively new, for like 6 years, 7 years, maybe 2013 started. So not many are there, but some of them are there, which researchers have frequently used. We can call them standard data sets. I wouldn't call them, because it does not address all the issues that I myself have pointed out in those data sets. So I'm not sure if we can consider them as a standard data set yet, but there will be much more data sets in future, I'm sure. Could you share how much undergraduates get involved with research in the US? Typically, I mean, the research spaces is okay. So it's a good question. So this is what I think I found very different from undergraduate programs in my country and undergraduate programs here. And not every school does that here as well. But at some point in time, during your undergraduate degree, if you are studying in the US, you will get exposed to research, even if it is like higher level course. If it is your 4th year, 3rd year, most of those courses are project based and presentation based and so on. And you'll have to read research paper, you'll have to implement something that has already been done. And then you'll have to think something new, and you'll have to write a paper at some point in time. And some people have kind of forced it through thesis requirement, that to graduate with a bachelor degree in computer science, you have to have submitted, you've done 6 months of thesis work, research work as an honor. So those sort of requirement actually push students, and some of the students are just interested in doing these cool things. So they're like, hey, what do I need to learn to get involved with your research? They will come to you, they will send an email to professor and they'll say, what are you working on? Let me get involved. Can I help you? Can I assist you? I just want to learn. So students here, since they pay a lot of money, and you can't think of like paying that much of money, or maybe even able to, public education should be free. That's what I advocate for. But the college that I was teaching recently, students pay $72,000 a year, and you can convert that to probably rupees multiplied by 70, so probably 50 lakhs, right? So it's like tuition and then housing and then everything else. But so whenever they're spending such money, they take everything very seriously. They come to your office hour, they ask questions, they get involved in everything that they can get involved in. So the research space is not reserved for MPhil PhD only here. It is also very prevalent at undergraduate level, especially in 3rd and 4th year, not 1st year, 2nd year, because we definitely need to develop core strength. Okay, there is another question. The possibilities are fascinating. The machine learning aspect is astonishing. Okay. What are the processes for establishing research ethics in this area? That's a very good question. So whenever we as a public get worried about anything, we start advocating for it, and we start making the government or policymaker to bring some sort of policy. So people's privacy and people's safety and other things can be secured. They are not revealed. When we talk about ethics in this area, I'm not sure what particularly ethics in this area could actually refer to one thing, that whether these systems are equally applicable or equally accurate for all types of population. For example, whether Gait biometric is as accurate for men as women, right? That could be a thing. For example, very recently, this whole field got into limelight when New York Times published an article that these facial recognition systems are not as accurate as they are for Black people, as accurate they are for white people, right? So there is a discrepancy. For white people, it is 85% accurate. For white people, it is 99% accurate. For Black people, it is 85% accurate. And also for women, if it is a Black woman, it is even less accurate, right? The accuracy drops down to 75% or something. And there is a movie, I think I will forward you that movie. It was produced at Stanford very recently. I forgot the name of the movie. It's a documentary, but it's very well-known documentary on ethics in this area. So first of all, as a researcher, we have to collect data from all types of individuals. We cannot just collect data from all women or all men or all younger people or all older people. So we have to diversify our data sets. That's the first thing as ethics in this area. And second thing is we have to make sure that whatever model we are developing, they are equally accurate for all types of people. They don't discriminate. These algorithm discrimination thing is a hot topic right now. I can give another talk on that. Probably I will have to prepare because that's not my area, but yeah, I'm trying to get into that area a little bit. Fairness, accountability, and transparency, trust. All these are buzzwords, especially in this area of ethics. I don't know if I answered your question, but.
Sir,
Mm-hmm.
So are there any prerequisites that needs to be started working on in the field of this research?
Yeah, you definitely need a couple of things, especially good Python programming experience, because all of these experiments have been, and then maybe Android development experience. You saw that to collect data, you need to know how to develop an app, and you also need to know how to, and you also need a little bit of statistics, maths, signal processing. So all those things, but you can learn them on the way. You don't have to take courses, all of these courses, one by one, and then get ready. It will take you 2 semesters to get ready. So it's better that you start reading these papers, and then whatever you don't understand, you go back to them and try to understand them. Let's say you are reading a paper and they have mentioned Fourier transform. You go and watch a video on Fourier transform and just learn about it. And then you wanted to learn about how KNN, K nearest neighbor algorithm works. You go and just watch a video and learn about it. So you should be willing to learn something new on the fly. That is a prerequisite for anything, I guess, to succeed or excel in anything, especially extracurricular, this sort of stuff, research. Yeah, knowing machine learning definitely helps, because you have to tune these algorithms, and then that is one of the difficult part. Those are the prerequisite, I would say. Little bit of stats, Python programming, machine learning experience, and then Android. These are the prerequisite. And yeah, that I would say. Somebody has asked
one more question in the chat box. Can these biometric devices harm humans?
I'm not sure what the question is referring to. I mean, harm humans means in what sense? They wouldn't fight with you. They are passive devices. Harm humans in the sense that the data that they are generating could be harmful to you. And like I said, somebody gets your information that are private to you. They can use it against you, or they can use it to make better things for you. And I think it's everywhere. Like Google collects every information that we search, so that it can customize search for us individually. And similarly, if somebody can collect these data, they can make your life easy or hard. And this is a double-edged sword. And then if they are trying to make your life hard, then that has to be covered by regulations or maybe technology. So in the US, there are 3 things that they follow to solve any problem, and I tell it everywhere in all my presentation. They follow a triple E model. One is engineering, education, and enforcement. So for example, let's say people overspeed, right? They are driving their car and they overspeed. So first of all, they will try to make their roads in such a way that even if somebody overspeeds, they would not get into accidents. And education, they will try to educate you. They will try to push you through a course that you take for 4 hours and know what, you overspeeding causes what type of problems to the society, and you should not do it. You must not do it. Third is, if you don't, good roads are there and you still overspeed, and then so they will enforce it. They will have policemen, they will give you tickets. You'll have to pay $1,000 just for overspeeding, maybe 20-30 miles per hour. So there's a lot of money that you'll have to pay that next time that you will not do it. So 3 things, I guess. And I think that applies to all the technologies that we are developing. So enforcement will come through regulations and policies. Did I answer? I don't know.
Sir, there was one question in the chat box, like so much data is being generated. So how and where it is stored, like cloud computing, or what is used to store it?
Oh yeah, I missed that question. So this data doesn't have to be stored, all of these data. You see, every time you give a fingerprint, it doesn't have to be stored. It just have to be masked and probably thrown away. It doesn't have to be stored. Yes, there is a lot of data. So there are a lot of people who have probably thought of this question, and they have proposed that this biometric data will be transmitted over the wire and they will be stored on the cloud. It can be done, but I don't think there is a need to store the data, except storing the security profile that you just saw in the video with Tom Cruise. Security profile is storage, and it will be encrypted. And next time you are giving a template, a fingerprint, it will be kind of featureized, and then probably compared with the stored template, and then it has to be thrown away. It doesn't have to be stored. Collecting this data definitely uses a lot of power from your device. But in future, we are envisioning that the way we have batteries driving cars now, we will have much more powerful batteries that will not run out in an hour or a day, even if we are trying to collect all this data from these sensors.
So many access control situations make use of a smart card along with a biometric. So why is it necessary?
Sorry, I may not have heard it properly. So can you ask the question again?
So can I repeat? Many access control situations make use of a smart card in addition to a biometric. So why is it necessary?
So you mean that why do we use both a smart card as well as biometrics? Or
Yes,
you're
sir.
saying that, okay. So the thing is, there is a transition phase that we as a end user of these technologies go in transition phase. Let's say a new biometric comes, and then all of a sudden you cannot replace everything else that existed before, right? So they have to do both at some point in time. Let's say there is a shopkeeper and he doesn't want to replace the card reader with a biometric scanner. Would you force that person to do it? Probably not. So we have to have like some sort of transition. Maybe 2 years later, that person would realize a lot of his customers or her customers are not coming because he doesn't have a good payment system, like biometric payment system. So he would replace it automatically 2 years later. And that's why at some point in time, when we are in transition phase, we have to have both. Does it make sense?
Yes,
Sir, I
sir.
have
Thank
one
you.
question. Sir, how soon do you think these techniques would become available for the public use?
How soon or how?
How soon these techniques,
Okay.
artificial intelligence and all, will become available for public use?
I think we have a long road ahead, maybe 5 to 10 years from now. I'm no more, I'm not a futuristic, like I can't forecast it, but I think at least 5 to 10 years, depending on how fast do we evolve, right? But
Okay.
smartwatch based payments are already there, and then maybe smartwatch based car unlock would already be there very soon, because big companies, whenever big companies start working on the technologies, that's the day, you know, because they will push through it. They have a lot of money, they have a lot of researchers, they have a lot of people, and they can solve any problem. As an academician, as a researcher in academia, in university, we just try to do fundamental research and we say, this particular idea has a promise. Now you as an entrepreneur or someone who wants to build a product out of it, do it, go ahead, it's your job to do it. Like, but as a student, you are in a situation where you can develop your own product and you can create your own company. A lot of students in the US do that whenever they have done some sort of research, they will open their own company, and that company sooner than later becomes a very big company, and they will start employing people from our country and some other places. That's how things work here.
Okay, great, sir.
Sir, I would also like to ask you, how should we encourage like our friends and all those undergraduates out there to get exposed to research of this kind?
Okay, so there is a quote by Elon Musk that if you need a motivational speech to do it, don't do it, right? Unless you feel compelled to do it, don't do it. So I think most of the times students have to feel that they want to do it, and what you have to do is just to reach out to your professor, and your professor probably have to forge some collaborations either in India or abroad, or maybe talk to the professor that I have 4 students and then they want to work on this particular problem. Would you be able to guide them? Like, I have been mentoring some of the students at IIIT Delhi, and I have published 2 papers with them. Some of them were master's students, some of them were undergraduate students, and one of them recently got into Cambridge University, UK. So you see, a hard work of 6 months to a year can open many doors for you abroad. Like, I'm not saying that everybody should come abroad. I'm also a nationalistic person. Like, I love my country, but the thing is, when you come here, you learn things, and then for example, if I had not come here, I would not be giving this talk today, probably. I mean, maybe giving this talk if I had done something great in my own country, but a lot of things I would not have learned, right? So I think we have to create that interface. A lot of people have to create that interface. And like, I'm having collaboration now, and then we are producing research papers. So India is also coming on the paper, US is also coming on the paper, and so on. Sorry, I got off the tangent. I forgot your question already. But yeah, they have to be passionate about the research. First thing first, and then they just have to reach out to their professors, and I think professors at Mata Sundari are very well connected, so they could definitely find people to work with.
Thank you, sir.
Any other question?
Yes, sir. in case of latent fingerprint, can it be used to access the original biometrics of a person?
There are people who have studied that problem, and the brief answer is, short answer is yes. But I've not studied it too much that I can elaborate on that. But I have heard that you can actually just, even through features, you can generate the raw data. And if I give you just the model, and then you can find out what type of data that particular classification model accepts. There's a lot of research going on, and all these things started in 2015 when there was a person called Ian Goodfellow who had applied to MIT and Stanford, and he was rejected for PhD program. So he developed something called generative adversarial network, and since then everybody has started kind of probing whether these machine learning models are secure themselves. You see what I'm trying to say? So similarly, we used to develop computer programs 15-20 years ago. Maybe our professors here at the moment can tell us more. But when we were writing those programs, we were not caring about if somebody will try to exploit these programs. But later on, maybe 5-10 years later, SQL injection attack happened, CSS attack happened, and many other types of attack happened. Then all of a sudden we were like, no, we need to secure these programs. We need to write programs that are secure, that nobody can exploit them, because these programs are now going to run nuclear plants or maybe our cockpit in the aeroplane. So a lot of other, similarly, machine learning based model, before they get deployed to the public use, they have to be probed as rigorously as possible. I think these are the concerns that we have at the moment, that anybody can have these data, misuse it, and then maybe have the model and then misuse it. And all these studies has to happen before it gets deployed. But I think there will be a point when some of these things will be addressed automatically by researchers.
Thank you, sir.
Any more questions?
Sir, I think all the queries have been resolved for now. Is there any more queries? Please write it down in the chat box if there are any.
Seems there are none. If you have any more questions, you can send me an email. My email is there. It's just my first name and second name at hofstra.edu. So you can send your questions and we can connect. And thank you so much for this opportunity. Everyone, it was nice interacting with you, and I hope I gave you something to think about. That was the purpose of this talk, I guess.
So before moving on towards the end of the session, I would like to request everyone to turn on their cameras for a sweet little picture. And I would like to request Team Cybernauts to take screenshots as well. So everyone, please turn on their cameras. So now, moving forward towards the end of the session, I would like to invite Ms. Twinkle Karki for the vote of thanks.
I would like to thank Dr. Rajesh Kumar for providing us such great and insightful information about behavioral biometrics. We are truly grateful for your words of wisdom, sir. They would surely help the participants in the long run. Now, I would like to take this very opportunity to thank the Faculty of Computer Science Department for their continuous support for the smooth conduct of this webinar, and to all the participants who joined us today for the session and showed their active participation. I hope all your queries have been resolved by our speaker. And last but not the least, I would like to thank Team Cybernauts for their overwhelming efforts towards organizing this learning session. Please do provide us feedback about the session. The link of the feedback form is being circulated in the chat box and in the comment section for YouTube. Thank you so much, sir. We will be looking forward for more such insightful sessions from you. Thank you. So the session is over. I request you all to please leave the call. Thank you so much once again. Signing off, Team Cybernauts. Have a wonderful evening.
Thank you, Rajesh. I guess he left it. Yes, he left it. So, बच्चे आपके पास जिसके पास भी right है, just unmute this and stop the recording and stop the YouTube video as well. Ma'am, how was the session?
Good. Interesting and informative. I couldn't leave.